Now I'm coming to one by one. We want to derive the continuity equation, that is conservation of mass. In that case, what should I do? I know that dN by dt system is equal to, now I can write down, because this is non-deforming stationary control volume, so I can write down simply like this, curly by curly t n rho dv triple integral control volume plus surface integral n rho v dot dA. Now for mass, what should be n equal to? What should be n equal to?
M.
What should I write down n equal to if I want to apply it for mass?
M, sir. Small
N. Small n?
1.
1. So what do I get? dm by dt system is equal to triple integral control volume curly by curly t, n becomes unity, so I'm only left with rho dv. What else? I know that n is unity here, so plus double integral control surface rho v dot dA. What is this term equal to for classical mechanics?
0. 0.
0. So what do I get? 0 is equal to these two terms. Are you clear? Right? Any doubts to anyone?
No, sir.
Now what is the problem here? If I want to equate these terms equal to 0, what do I need to convert? Either I convert both to surface integral, or I convert control CS to CV or CV to CS. मतलब यहाँ पे एक है वॉल्यूम इंटीग्रल और एक है सरफेस इंटीग्रल. मुझे एक ही तरह के चाहिए, तभी मैं उनको लिख पाऊंगा प्रॉपर्ली. ये क्लियर है आपको? Clear? So for that, I have a theorem. I think you might have heard about it. Gauss divergence theorem. How many of you have heard about this theorem? Gauss divergence theorem. हाँ जी, किसी ने सुना है इसके बारे में? Anyone? So this is a theorem that converts surface to volumetric or volume to surface integrals.
Sir, it was in physics last year.
So you have studied this?
Yes, sir.
So what does that state? What does that state? This is also called fundamental theorem of divergence. Fundamental theorem of divergence. Now, honestly, please frankly tell me how many of you are comfortable with divergence, curl and gradient, because I touched this, I think, in third, fourth lecture also, but now it is necessity. You will have to go through it, otherwise you will not understand the next part. How many of you are clear with the concepts of curl, divergence, gradient and these fundamental theorems? Hanji. How many of you are comfortable?
None of us, I guess, sir. Very few, maybe.
Okay. So I will give a 5 minutes review only. If you want to learn more, then what I can do is I will send across the recorded videos to you. There are two, maximum 45 minutes video. I will not cover it here, but for this derivation, I will review that in only 5 minutes quickly. So now let me know if you remember वेक्टर्स पता है सबको? All of you know vectors?
Yes, sir.
So if there is a vector A, if you multiply this with a constant, this is one operation that you can do on a vector. That is, say A was 2i plus 3j plus 4k and A was say 3. So you can actually multiply with 3, then each of the term will get multiplied by 3, each component. ये तो clear है? What about this? What is this? What is this?
Dot product.
This is called dot product, or also called, I think you might have heard, inner product. So when you apply with a constant, a vector, what do you get? Scalar or a vector?
Vector.
Vector.
Vector only. What about this case?
Scalar
What is
quantity.
scalar or vector?
Scalar.
Scalar. What about this case?
We get a
Vector.
vector quantity.
So this is called
Cross
cross product, and you get a vector. Are you clear? Hai? Any doubts? Now likewise, you should remember these del, this gradient, divergence and curl. This del operator is a vector differential operator. It has similar properties as of a vector, although it operates on whatever follows it. So del, this is called also Nebra operator or del operator. This is I curly by curly x plus j curly by curly y plus k curly by curly z. ये तो clear है सबको? Now, if you make this operate on a scalar function, say t, so t is a scalar function, then what will you get? You will get gradient. So this is called gradient of scalar function t. Now can you tell me what is the difference between scalar and scalar function?
The functions में variables भी हो सकते हैं.
तो फंक्शन में वेरिएबल होंगे, इट विल बी डिपेंडिंग ऑन मेनी अदर इंडिपेंडेंट वेरिएबल्स. ठीक है? सो दिस इज कॉल्ड ग्रेडियंट. एंड ग्रेडियंट विल बी अ स्केलर और अ वेक्टर क्वांटिटी?
The vector.
Vector. So gradient can be of a scalar function or a vector function also. So please remember, gradient can only be of a scalar function. You cannot have gradient of a vector function. So this is just analogous to this first part, but the only difference here is, here you are multiplying and here A is not a function but a constant, but although it is a scalar, here it is a function and you are operating on this scalar function. So this is gradient. तो एक तो आप ऐसे कर रहे थे, दूसरी में क्या कर रहे थे? डॉट प्रोडक्ट कर रहे थे. तो इसमें क्या कर सकते हो? del dot A. This is called divergence of A. तो डॉट प्रोडक्ट ले लिया, इसका मतलब जिस पे ये ऑपरेट होगा वो क्या होना चाहिए? वेक्टर. So divergence of A should be a scalar or a vector quantity?
Scalar.
Scalar quantity. थर्ड कैसे एक्ट कर सकता है? So this is called curl. This is called curl, and what will be curl? A scalar or a vector quantity?
Vector.
वेक्टर क्वांटिटी। हाँ जी, क्लियर है अब? सो प्लीज रिमेंबर दिस एनोलॉजी, you will never ever forget this. So I have written down here, so this is gradient, this is divergence, and this is curve. So you can always remember these three by these commonly used vector operations. हाँ जी, clear है? Any doubts to anyone? Any doubts to anyone? Now I am quickly coming to the theorem, and this is so powerful a statement that if you remember the statement, you will never ever have to remember any kind of mathematical formula. Otherwise, it will be very difficult for you to remember the formulas alone. So I'm giving you 30 seconds. Read out this statement, and this statement, if you remember, you will remember every theorem, that is Gauss divergence theorem, Stokes theorem, fundamental theorem of gradients, all the theorems you will remember if you remember this statement and understand this statement. So what does that state? The integral of a derivative over some region in space is equal to the value of the function at the boundaries. So let's first apply this statement to a simple integration formula. तो आप जो करते हो, मान लो ऐसे कर दिया मैंने a b fx dx, ठीक है? और मान लीजिए मैं ऐसे करता हूं, say fx is equal to x square, fx is equal to x square. Now what will be df by dx equal to? If I say what will be df by dx equal to 2x.
Yes, sir.
So I am writing down here, now please be careful, I am writing down here fx is x square, df by dx is 2x. I am putting it here. Now what is this? Integral of a derivative over some region in space. अब लाइन इंटीग्रल के लिए स्पेस क्या हुई? एक पाथ. हाँ जी, what is the domain of a line integral? A path, any kind of curve. So integral of a derivative, this is integral of a derivative over some region in space. Region in space का मतलब हुआ इस पाथ पे, is equal to the value of the function at the boundaries. किसी भी लाइन की बाउंड्री क्या होती है? किसी भी लाइन की बाउंड्री क्या होती है? अगर मैं कहूं दिस इज द लाइन, व्हाट इज द बाउंड्री ऑफ द लाइन?
Starting and end points.
End points. So these are the boundaries of the line. So by this definition, what should be the answer? The integral of a derivative over some region in space is equal to value of the function. Function क्या है यहाँ पे? f. तो क्या होना चाहिए? f at b minus f at a. What is f at b? What is f at b? X square. So b square minus a square. अगर आप वैसे भी करते, आप सिंपल ले लेते, इसको मान लेते f कैपिटल, आप ऐसे करते जो आप नॉर्मली करते हो, तो क्या आता आपके पास आंसर? 2x dx इंटीग्रल a टू b. इसका भी आंसर क्या आता? b स्क्वायर माइनस a स्क्वायर. मैं क्या कर रहा हूं? मैं इंटीग्रल कर रहा हूं एक डेरिवेटिव का. That should be clear in your mind. तो जो भी आप फंक्शन लिखते हो, तो you should always look at an integral in such a way that this is representing the derivative of some function. So when I say x cube or I say x square dx integral a to b, you should always think x square as x square is some function of some derivative, is the derivative of some function, so that f becomes equal to x cube by 3. So you have two choices, either simply integrate this or by this theorem, integral of a derivative. Now derivative is this only, so you are integrating this only, nothing has changed, but you can simply write down is equal to the value of the function. You already know this is the function, so you can simply write down b cube 3 by minus a cube 3 without even solving this, because you know this is the function. So although this may look to be weird in this case, but it will help you a lot when you write it down for the case of Stokes theorem, divergence theorem and all those. So now I'm coming to that point. First one is fundamental theorem of gradients. So integral of a derivative, इसमें derivative आपने gradient ले लेना है. This is what? A vector or a scalar?
Vector.
Vector. So this is a vector and you want to integrate, so you will want to make it a scalar quantity. So now let me know. So this was a staircase and this was top of the house. You want to measure this height, कि इस छत की height क्या है. आप कितने तरीकों से कर सकते हो, या तो आप स्केल लेके जाओ, इन स्टेप्स की हाइट को मेजर करते जाओ और उनको ऐड कर दो, यू विल गेट द नेट हाइट. और ये एक तरीका है, समझ आ रहा है आपको कि आपने ये मान लो h1 था, h2 था, h3 था, आपने तीनों को जोड़ दिया, दैट इज द टोटल हाइट ऑफ दिस रूफ. व्हाट इज द अदर वे आउट? You measure this height from a datum, you measure this height from a datum. You simply subtract the two. So this was a capital H1, this was capital H2. So you know that H1 minus H2. So this is the other way. Now try to think, this is a summation, so this represents the integral. So delta T or delta H dot di means your displacement. So integral of a derivative, ये मान लीजिए a है, ये b है, integral of a derivative, इसमें derivative क्या है, ये derivative is, sorry, this over some region in space. What is the region in space here? The region here is this line should be equal to the value of the function at the boundaries. So what is the function here? This. So this is TB minus TA. So finally the theorem becomes integral of a derivative. Here derivative is gradient over some region in space. Some region in space is the line element, is equal to the value of the function. Function क्या है यहाँ पे? T at the boundaries. Boundary क्या होंगी? Endpoints A and B. So this is called the fundamental theorem of gradients. Now I am coming to fundamental theorem of divergence or Gauss divergence theorem. तो divergence में क्या होगा? जो derivative है, that is this. Derivative is now divergence. तो divergence जो है वो किसी वॉल्यूम में से होते हैं, क्योंकि ऑलरेडी आप ऐसे भी याद कर सकते हो कि दिस इज अ स्केलर क्वांटिटी. सो आई विल मल्टीप्लाई दिस विद डाइवर्जेंस इज ऑलवेज फॉर अ वॉल्यूम. सो इंटीग्रल ऑफ अ डेरिवेटिव, इंटीग्रल इसमें क्या आएगा? वॉल्यूम इंटीग्रल ऑफ अ डेरिवेटिव. डेरिवेटिव इज दिस डाइवर्जेंस ओवर सम रीजन इन स्पेस. रीजन इन स्पेस इज द वॉल्यूम, शुड बी इक्वल टू नाउ मुझे बताइए एक वॉल्यूम का बाउंड्री क्या होती है? व्हाट इज द वॉल्यूम ऑफ अ बाउंड्री? सॉरी, व्हाट इज द बाउंड्री ऑफ अ वॉल्यूम? इफ देयर इज अ वॉल्यूम हियर, व्हाट इज द बाउंड्री ऑफ द वॉल्यूम? सरफेस एरिया। हाँ जी, क्लियर है? राजंश,
यस सर।
हाँ जी, क्लियर हो रहा है कि नहीं?
यस सर, अभी तक तो क्लियर है सर, मतलब वॉल्यूम इंटीग्रल एंड डाइवर्जेंस थ्योरम।
हाँ, तो इसमें क्या है? इंटीग्रल हियर, इंटीग्रल इज वॉल्यूम इंटीग्रल
यस सर।
ऑफ अ डेरिवेटिव। डेरिवेटिव यहां पे क्या है? डाइवर्जेंस
Divergence.
यस सर।
ओवर रीजन इन स्पेस। रीजन इन स्पेस क्या है? वॉल्यूम
वॉल्यूम
इज इक्वल टू वैल्यू ऑफ द फंक्शन। फंक्शन क्या है यहां पे?
वी।
v ओवर द बाउंड्रीज। बाउंड्री क्या होती है वॉल्यूम की? एक वॉल्यूम की बाउंड्री क्लोज सरफेस होता है।
यस सर।
Now try to see with that statement. Integral, here the volume integral of a derivative. Derivative is divergence over some region in space. Region in space is volume, is equal to the value of the function. Function is v. Over the value of the function at the boundary. So boundary of a volume is a closed surface or the control surface. That's why this is control surface and this is a circle depicting that it will be a closed surface. So this is called your Gauss divergence theorem or fundamental theorem of divergence. So this is Gauss divergence theorem. And third one is, now help me do this, integral of a derivative. Now derivative is this curl is the derivative. So by logic, what should always be? It should be, this is a vector, I want to convert it into a scalar. So this is integral of a derivative over some region in space. So here region is a surface. So I will have a surface integral. But please remember, here surface is not closed surface. So a plain sheet of paper is a surface. It is not a closed surface. So fundamental theorem of curls or Stokes theorem is applicable to plane surfaces, not closed surfaces. So integral, here surface integral of a derivative, here derivative is curl over some region in space, here region in space is the surface, is equal to the value of the function. Now what is the function here? v. एक सरफेस का, प्लेन सरफेस की बाउंड्री क्या होती है? If this is the plain paper,
The
what
area.
is the boundary of this plain paper?
एरिया आएगा।
Boundary,
बाउंड्री पेरीमीटर।
perimeter. So what should I do? What the v dot di closed line integral.
यस सर।
So these are the theorems you need to always remember, and it is very easy to remember if you see the underlying thing. So this was the first, a to b df by dx into dx is equal to fb minus fa. So this is called fundamental theorem of calculus. This is called fundamental theorem of gradients. This is called fundamental theorem of divergence or Gauss divergence theorem. And this is called fundamental theorem of curls or Stokes theorem. And clear hai? Any doubts to anyone? Any doubts to anyone? Akash,
Yes, sir.
and clear hai?
Yes, sir.
Now let me know I have already written down in case of mass, this was 0 and this was triple integral control volume rho dV plus double integral control surface. This was rho V dot dA. Now I want to convert this to a volume integral by Gauss divergence theorem. What will be the value? What will be the value?
Dot V dot dA.
So I should write down triple integral control volume. अब बताइए
Del operator
डेल ऑपरेटर
dot
डॉट
V vector.
अब इसमें देखो किसको डॉट किया हुआ है
V vector है सर, रो तो कांस्टेंट है.
रो कांस्टेंट नहीं
Yes,
है
sir.
रो क्यों कांस्टेंट है
अच्छा रो, ओके सर. अगर वेरिएबल है तो V रो इनटू V वेक्टर
रो वी और यहाँ पे क्या कर दूं
dV.
डी क्लियर है एनी डाउट्स टू एनीवन सो आई हैव कन्वर्टेड फ्रॉम
रो
सरफेस
कैसे कौन वेरिएबल है सर, ये समझ नहीं आया.
क्या कह रहे हो
वो वेरिएबल क्यों लिया हुआ है हमने यहाँ पे, ये समझ नहीं आ पा रही बात.
अच्छा आप ये ध्यान से देखो अब मैं यहाँ पे लिख रहा हूँ एक बार ध्यान से देख लो अब मुझे
Yes,
आप
sir.
बोलो गॉस डाइवर्जेंस थ्योरम की वैसे मुझे बताओ क्या स्टेटमेंट होगी इंटीग्रल ऑफ अ डेरिवेटिव डेरिवेटिव हम लेते हैं डाइवर्जेंस
यस सर.
integral of a derivative over some region in space
ये वॉल्यूम.
is equal to the value of the function at the boundary.
यस सर. यस सर.
ठीक है तो इंटीग्रल ऑफ अ डेरिवेटिव मतलब डाइवर्जेंस ऑफ अ फंक्शन
यस सर.
अब यहां पे फंक्शन क्या था v
यस सर.
यहां पे फंक्शन क्या हो सकता है आप इन दोनों को कंपेयर करो या आप इसको इन जनरल ऐसे कर लो अगर आपको ऐसे कंफ्यूजन हो रही है मैं ऐसे बोल देता हूं इसको ये a है ये भी a है अब क्लियर है
यस सर.
a तो हो ही
Yes, sir.
सकता है कुछ भी वो ये भी हो सकता है कुछ भी हो सकता है
यस सर. यस सर. नाउ गॉट इट.
गॉट इट
यस सर. यस सर.
So what do you get finally? Now you can take out this as common. You get curly. What else? Curly. What should I write down? Curly. Here was some this also. Sorry, curly by curly t also. So I get curly rho by curly t plus what else? V or sorry del dot rho v. This is equal to what? 0. Are you clear? Any doubts to anyone? This is the expression. Any doubts to anyone? This expression में. Now dv is arbitrary, but you know that it is always equal to 0. What does that mean? So this term should be equal to 0.
यस सर.
So what does that tell you? Curly rho by curly t plus del dot rho v should be equal to 0. And this is called the continuity equation. This is called the continuity equation. अब ये भी continuity equation थी जो आपने पहले बताई थी ये भी continuity equation है ये भी continuity equation है जो आपने पहले बनाई थी this is only one of the formats of the continuity equation and you can write down this in a more simpler form curly rho by curly t plus I curly by curly x plus j curly by curly y plus k curly by curly z. You dot it with rho ui plus rho vj plus rho wk. So you get finally curly rho by curly t plus curly rho u by curly x plus curly rho v by curly y plus curly rho w by curly z. this is equal to 0. So this is the continuity equation and the conservation of mass equation expressed in differential form. जो अब आप बात कर रहे हैं कि अगर रो कांस्टेंट हो, then you are left with this term goes to 0 and rho comes out of the derivative term and you are only left with curly u by curly x plus curly v by curly y plus curly w by curly z. तो आप ज्यादातर ये इक्वेशन देखते हैं क्वांटिटी इक्वेशन में, but this is by making this simplification. Originally the equation is this. Any doubts to anyone? Any doubts to anyone? So we have actually derived the continuity equation using Reynolds transport theorem. That is, we took a finite size control volume. So now try to see if you have observed it carefully. This was the equation. So here it is rho dv and it is same v dot ds. So this is the equation you got, and finally you change this equation to equation like this. Are you clear? Hai? You started with this equation and simplified to this equation. Likewise, you could go to other routes as well. तो जो 4 models of flow थे, अगर मैं वहां से शुरू करता, किसी से भी शुरू करता, मेरे पास इक्वेशंस ही आती और ये इक्विवेलेंट होती इक्वेशंस. So that is the beauty of this. Whichever model of flow you follow, it does not matter. You will get an equation which are equivalent to each other. Now one last thing, then I will break for today. I want you to derive the quantity equation for infinitesimally small control volume fixed in space. हमने अभी जो किया है वो है infinitesimally control volume finite control volume fixed in space के लिए हमने किया है Reynolds transport theorem से. I want you to derive for infinitesimally control volume fixed in space. जैसे मान लो यहाँ पे कोई फ्लूइड फ्लो कर रहा था, आपने उसमें से एक छोटा सा फ्लूइड एलिमेंट उठा लिया और वहां पे आपने उसको एनालाइज करना स्टार्ट कर दिया. So how will you do it? Quickly. This is the last part, then I will break for today. How will you do it? This is infinitesimally or differentially small control volume fixed in space. So how will you do it? So this is x, this is y, this is z. अब इसमें से फ्लूइड फ्लो कर रहा है, इधर भी इधर भी इधर भी इधर भी, इस तरह से भी फ्लो कर रहा है. तो हम सिंपल करें जो आप छोटी क्लासेस में भी करते थे. अगर रो डेंसिटी है, ये मान लीजिए dx है, ये dy है और ये dz है. तो x डायरेक्शन में किस किस फेज से फ्लो हो रहा होगा? ABCD and EF G D. Any clear है? Any doubts? Any doubts? So what should I write down here? Whatever is entering the differentially small control volume and whatever is exiting the differentially small control volume should be equal to what? The rate of change of mass within the control volume. But here the control volume is differentially small. That is the only difference. So mass flowing into the system will be equal to what? Mass flow rate flowing into the system will be equal to what? In x direction. What will be the mass flow into the system in x direction? Akash.
Flow.
Sir, rho into dA into V, मतलब
रो
A
इंटू कुछ
A
इसकी
जो,
वेलोसिटी होगी,
यस सर,
मान लो
V
एक्स
velocity
कंपोनेंट
होगी,
उसका u है, तो मान लो इसकी टोटल वेलोसिटी है ui प्लस vj प्लस wk, तो मैं क्या लिखूं x के लिए, रो इंटू u
U,
इंटू एरिया क्या है dz इंटू dy,
यस सर,
तो dy इंटू dz, ये इसमें एंटर कर रहा है इस रेट से। एग्जिट किस रेट से कर रहा होगा मुझे पता नहीं, लेकिन मुझे ये पता है कि अगर कोई फंक्शन यहां पे है तो दिस वाज एट से फेस ए बी सी डी, व्हाट विल बी एट फेस ई एफ जी डी, क्या होगा, रो यू, सॉरी आई शुड पुट हेयर, एक सेकेंड, यहां पे डी वाई डी
into dz आएगा सर,
इंटू डी जेड, तो यहां पे क्या होगा, ई एफ जी डी में रो यू प्लस करली रो यू बाय करली एक्स इंटू डी एक्स। किसी को कोई डाउट हो प्लीज आस्क मी। दिस इज द मास फ्लो रेट एट ई एफ जी डी। हाँ जी, क्लियर है। जैसे अगर हमारे पास कोई यहां पे फंक्शन है एफ एक्स, या मान लो यहां पे कुछ है से, यहां पे अगर कोई u है, तो x, मान लो ये डिस्टेंस है l, तो इस पे u क्या होगा, हम ये लिख सकते हैं u प्लस करली u बाय करली x इंटू एल। ये क्लियर है आपको। अगर किसी फंक्शन की वैल्यू यहां पे u है, तो l डिस्टेंस पे उससे u प्लस करली u बाय करली x इंटू एल होगी। अब ये करली u बाय करली x अगर पॉजिटिव है तो u से बड़ी वैल्यू होगी, अगर नेगेटिव है तो ये u से छोटी वैल्यू होगी। ये क्लियर है आपको, आप ऐसे करते रहे हो मैथमेटिक्स में। हाँ जी, क्लियर है। तो यहां पे फंक्शन ये रो u था पहले, अब ये फंक्शन क्या होगा, रो u प्लस चेंज इन रो u अक्रॉस दिस डिस्टेंस dx। हाँ जी, क्लियर है। एनी डाउट्स टू एनीवन, एनी डाउट्स टू एनीवन। तो नेट एग्जिट इन एक्स डायरेक्शन क्या हुआ, नेट एग्जिट इन एक्स डायरेक्शन इज करली रो u बाय करली x dx dy dz, क्योंकि ये दोनों कैंसिल हो गए आपस में, this has got cancelled with this, so you are left with curly rho u by curly x dx dy dz. So this is the E flux in x direction. Likewise you can have E flux in y and z directions. So total E flux from the differentially small control volume becomes curly rho u by curly x plus curly rho u by curly y plus curly rho u, rho v by curly y, curly rho w by curly z into dx dy dz. Now you know that this is the rate at which it is E flux, and you know that mass into minus mass out should be equal to rate of change of mass stored. And what is mass stored? Rho into volume. So volume is what? dx dy dz. This is at rate, so this is by delta t. In the limit delta t tends to 0, so I am left with curly rho by curly t dx dy dz. So I am finally left with curly rho by curly t plus curly rho u by curly x plus curly rho v by curly y plus curly rho w by curly z, and I have here dx dy dz is equal to 0. So I am again left with the same expression which I got from Reynolds transport theorem. So this reinforces the concept that whichever route you follow, you will end up in the same equation. Those could be converted to one another. So that is the beauty of this analysis. So I will break for today. I don't know. I am skeptical whether you have understood it or not.
So you
But
can
if
just take
you
to the
haven't
last
understood,
part.
हाँ जी,
Yes sir, last part एक बार दोबारा
The
explain करो.
last part explain ही वो statement नहीं दिखती सर last में आपने जो
कौन सी वाले की? कौन सा पार्ट?
put mn minus m out is equal to
हाँ,
M-
आपको जैसे अगर कोई है, जैसे हमने टब की बात की थी कि यहाँ पे कुछ इन आ रहा है, यहाँ से कुछ आउट जा रहा है, तो किस रेट से इसमें इंक्रीज हो रहा है? आपको याद है?
yes sir.
तो आपने जो
yes sir.
तो जो आपने रेनॉल्ड्स ट्रांसपोर्ट थ्योरम में भी किया था, आपको याद होगा, ये था ऐसे, माइनस आप करते थे इनफ्लक्स प्लस ई फ्लक्स। तो ये वाली जो टर्म है इनफ्लक्स ई फ्लक्स, ये तो बेसिकली यहां से आ गई जो आपको कि कितना रेट से ई फ्लक्स हो रहा है तीनों डायरेक्शन में, तो आपने वो ऐड कर दिया। प्लस अब ये क्या ऐड किया आपने, करली रो बाय करली जो टी आया वो कहां से आया कि आपको पता है मास फ्लो रेट इस डिफरेंशियली स्मॉल कंट्रोल वॉल्यूम में, वॉल्यूम इसका है dx dy dz, तो मास हो जाएगा रो इनटू दिस। तो ये कितना चेंज हो रहा है, इट मींस आई शुड डिवाइड बाय डेल्टा टी, द लिमिट डेल्टा टी टेंड्स टू 0, so this becomes curly rho by curly t into dx dy dz. So adding the two terms, that is curly rho by curly t, this is the rate at which the mass is increasing because it is multiplied by dx dy dz also, although it has become common, and this term represents the rate of efflux from the differentially small control volume. And if you see carefully, this is the same expression you got using Reynolds transport theorem.
Yes.
So this is the continuity equation, that is the conservation of mass equation. And in the next lectures, we will be doing other equations, that is when we are conserving linear momentum, angular momentum, energy, then you will end up in Navier-Stokes equation, Euler equation, Bernoulli equation. So it is as simple as that. You only need to change the value of capital N and small n, nothing more than that. You will get the answers. So that is the beauty of this analysis. And any doubts to anyone now? Otherwise, I will end the meeting now. Any doubts to anyone?
No sir.
Okay then, I am ending the meeting now.
Explain sir.
हाँ जी,
सर एक बार वो जो EF GD वाला जो फेस था वो वाले पार्ट से समझा दो एक बार लास्ट में.
EFGH वाला?
यस सर, ये वाला पार्ट.
अच्छा, एक सेकेंड रुको। मान लो एग्जाम्पल मैं बोलूं, यहां पे कुछ टेम्परेचर है 10 डिग्री सेल्सियस,
यस सर.
यहां पे ये इससे 5 मीटर की दूरी पे,
यस सर.
मैं आपको यहां पे टेम्परेचर पूछ रहा हूं, तो आपका क्या क्वेश्चन होगा मेरे से कि टेम्परेचर, मैं आपको बोल दूं कि टेम्परेचर एक्स डायरेक्शन में, मतलब टेम्परेचर ऐसे है,
यस सर.
तो आप क्या करोगे? व्हाट विल यू,
सर रेट ऑफ चेंज निकालेंगे.
ठीक है ना? तो आप क्या कहोगे कि मान लो ये T1 था और ये T2 था, तो आप बोलोगे कि T2 किसके बराबर हो सकता है? T1 प्लस करली T बाय करली X इंटू 5।
सर ये इंटू 5 क्यों आ रही है?
देखो ये क्या चीज है, करली T बाय करली X क्या चीज है?
सर रेट ऑफ चेंज ऑफ टेम्परेचर.
रेट ऑफ चेंज ऑफ टेम्परेचर। तो रेट ऑफ चेंज
Yes,
का
sir.
मतलब क्या हुआ कि डिफरेंशियल
Yes, sir,
स्मॉल
yes, sir,
एक्स
आगे
से मूव
समझ गया.
करते हो तो डेल्टा टी चेंज होता है।
यस सर, यस सर, यस सर, गॉट इट.
तो ये यूनिटरी मेथड ही हो गया ना जो आप छोटी क्लासेस में पढ़ते
यस
थे।
सर, यस सर, यस सर, यस सर, आगे सर.
ठीक है, तो ये अभी समझ आ गया। तो
Yes, sir.
इसमें वेरिएबल अब टी नहीं है, क्या वेरिएबल है?
So you.
रो यू या रो वी अगर वाई डायरेक्शन में, या रो डब्ल्यू अगर
That direction.
जेड डायरेक्शन। हाँ जी, क्लियर है?
Yes sir.
Any doubts? So if you don't have any doubts, then I will end the meeting now. Okay then.